actually. And so, I don't know if you've ever played with Kubernetes before, Kalen, but getting a Kubernetes cluster is kind of a complicated thing.
No, I have not, and I'm really disappointed that it's this complicated.
So if you were to manually do it, you have to set up multiple control plane nodes as well as worker nodes. But most of the
Mm-hmm.
managed cloud services host the control plane for you.
Mm-hmm.
So and then you also don't pay for that. You only pay for the worker nodes.
Oh, really?
Um,
So the
but
controllers are like the server nodes and the architecture stuff
yeah, so
that
like the
like
way
handle that manage the works and like allocating new nodes.
yeah, so like all of your workloads run on your worker nodes, but then
Mm-hmm.
all of the orchestration and stuff runs mainly on the control plane. But there's some
Yeah.
stuff that runs on the worker nodes too. But
Okay.
so even paying for the worker nodes though is also like not super cheap. So,
Mm-hmm.
but if you go and look at GKE for instance, if we load
Mm-hmm.
here on this free tier, you'll notice that the GKE cluster is part of it. They never charge you for the management.
Mm-hmm.
And then the other thing that's always free is you get one micro instance per month and 30
Mm-hmm.
gigabytes of hard drive space per month.
Pretty good.
Yeah. So you can make a free Kubernetes cluster on basically one free node.
Mm-hmm.
I mean that's not that interesting though because why use a container orchestrator if you're only going to use one node, right?
Right. Yeah.
So we're going to deploy three. It will
Mm-hmm.
be less than free. It's going to be like a little over $5 a month.
Yeah.
But
Still pretty nice.
I would say I don't think that'll break the bank too much.
Yeah. That will work.
But so I'm going to do it just kind of manually at first in this UI, which
Mm-hmm.
I think is probably quite small for you.
Yeah. That works.
But if I go and create my cluster, I think these presets are a little better. The first cluster, your first cluster kind of
Mm-hmm.
thing. So we want zonal because regional. It explains it pretty well though. Zones is like only one single zone, where regions like deploys in multiple zones,
Right. Yeah.
um, and that it costs more to do regional. So we'll do zonal
Why does it cost more to do regional?
because it deploys more workers.
Hmm.
It's just like one per zone.
I see.
Um, the zones I don't think really matter that much.
I see.
I'm in central, so central. This also doesn't affect the price, so I'll just pick the newest one.
Mm-hmm.
Now our
And
number
this is like the flavor of this,
yeah.
like
So this is the
the
Kubernetes.
latest Google. Yeah.
Yeah,
Good.
Kubernetes version 112, and then like GKE has their own
Mm.
versions tagged onto it.
Okay.
And then node pools are like where your actual like worker nodes are going to be. So we're going to make three, and then I actually don't. I think this is the one micro whatever, but we want to
Yeah.
change the boot disk because we only get 30 gigabytes free, so we're actually going to change it.
So like 3 divided by 10,
Yep.
or 30 divided by 10. 3.
Yeah. So 10
I
each,
did the math before. Yeah.
and then we're going to use preemptible nodes.
Okay. Yep.
So that
That is. Yeah. That is to where they can get canceled.
yeah. So they live at most 24 hours, which is kind of an interesting concept, especially for Kubernetes, because if your node dies, it'll
Mm-hmm.
just reschedule all your pods, which
Okay.
is like the basic unit of work.
Right.
So in theory, you don't care if your node dies, and it actually kind of like is a nice little test of Kubernetes being able to orchestrate your workloads under, pretty extreme conditions.
Mm-hmm.
But
Yeah. So that will. So it will stop. So if I do 3 nodes, that will stop them, and then if I get more work, it'll spin them back up.
so I think your preemptible node lives at most 24 hours, but it'll still try to
Mm-hmm.
spin one back up, I believe.
I see.
Whether or
Okay.
not that's true is another thing. But there's another like Kubernetes controller that integrates with the GKE preemptible nodes, so that it actually like kills the nodes preemptively. Actually, um, so that you're never like you don't want all three to die at once, essentially. So it like rotates that out and then gets you a new one. Yeah.
Yeah. So we start them all at the same time, and they're all running. We wouldn't obviously want them all to die at the same time.
Yeah.
I guess.
Yeah, because then you would have an outage.
Yeah. Right.
I'm just gonna leave all of this stuff for now, and then if we go down here,
number of GPUs. We don't want to do any GPUs here.
I do not right now. I'm going to turn this off. Enable HTTP load balancing.
Why is that?
So, first of all, it's very easy to accidentally deploy a load balancer in Kubernetes. It's just like service of type load balancer, which is pretty common to find on the internet of a manifest. And then these are like $20 a month. These HTTP load balancers. And
so you're saying that it's easier to build your own? Is that what you're saying, or?
Yeah, so you can do some like hacky things where you could just have an extra VM sitting outside, which would be like $5 a month kind of thing.
I see.
Or
rather than doing, go ahead.
Yeah, or you can route to the actual Kubernetes nodes directly. You can just sync your like DNS records to the nodes.
Yeah, but it would be to each individual one though, right? You would have to. Is that what you're saying, right?
So there's a concept called ingress, which is like how things get into the cluster.
Yep.
So you'd have to run an ingress on each node, and then like the common way to do it, or like the easiest way, I guess, is like you would just expose a node port. So every like worker node would have the same port open for like basically ingress to anything, and then from there the ingress controller like routes it to your actual workload.
I see, but there's no sort of concept of like it seems like a simple form of it, right?
Yeah. So like otherwise you would just do an ingress with a load balancer in front of it. So you still only need one load balancer, but then your ingress is kind of fanning it out from there.
Yeah.
But so like as soon as you were like in production, like you should do that,
I see.
But just for playing around with it, I think it's a bit overkill. And then like I won't even be doing the ingress thing. You can still get to your stuff. It's just a little hackier and more for like development. If we go down here, I'm not enabling logging, which I think this used to be the default, was to enable it.
And this is to save space. So
yeah, like Stackdriver's nice, but you pay for space. If you look at the free tier, I mean, you actually get a fair amount free.
Like for the logging?
Yeah, 50 gigs of logs with 30-day retention. But I mean, that if you're actually running things in the cluster, I feel like you could really kind of easily get logs because it logs like literally everything. Okay. I think those are like OS logs. Monitoring is kind of the same story, and then there are other like open source projects that'll cover that. You're kind of trading off you running it versus Google running it. But this is just extra pools, but we're not going to use that.
Okay.
So if we create, this is normally like 5 minutes, but we'll see.
Your first cluster -1.
Yeah. So I guess I'm just gonna kind of move on while we wait for that. So that's just like we entered all that stuff manually, and we did it through the UI, which probably isn't super scalable. This repo that I have, it's this like cheap managed Kubernetes, uses Terraform, which is like a declarative infrastructure provisioning thing, and it works off of like a provider and plugin architecture.
Okay.
So if we go look at the main file, which I'll actually do in VS Code, and then close that. Is it big enough for zoom in?
Yeah, I think this is fine.
So we're saying we're going to use our Google provider with our specific project, our region, and our zone. These are variables that are defined in a file elsewhere.
Okay.
And then we're going to make our GKE cluster, which they refer to as Google Container Cluster.
Okay.
Specify the zone again, turn off logging and monitoring, and turn off
So this just
HTTP load
maps back to the window that we were just looking at.
Yeah, pretty much everything that we went through and configured manually in the UI, you can just say here. And you can actually do that. Like the Google Cloud has an API as well. It's just that this is pretty generic across cloud providers, at least Terraform itself. And you would just have to figure out their specific resource.
I see.
But yeah. So yeah, turn off load balancing. This was already defaulted to off, but the Kubernetes dashboard comes with, and it requires like elevated permissions in its current state. So
that's just like some high level like admin type things.
Yeah, it just shows you what's running
on
a nice little UI. But we'll actually see that Google does that as well.
I see. Okay.
We removed the default node pool, and this one, I don't necessarily know why, but the Terraform docs recommend that you manage it separately. Presumably, I guess you can just have more than one, and the life cycles aren't tied together, is my guess. But yeah, so we just say we only want one node, and then we'll actually delete it as soon as the cluster comes up, and we'll use this node pool, which we link.
Oh, interesting. Yeah, so we define our own node pools. I see.
Yep, and we link it here with this cluster attribute, and then this is part of Terraform where you can interpolate things from the previous resources. So we have the resource, Google Container Cluster .primary, and that has an attribute of name.
Oh, interesting. So it auto built out because we basically gave this thing a name, right? Can we scroll back up, please?
Yep. Yeah, I picked the name. My poor GKE cluster.
Oh, but our resource. Can we go to how we defined how we tied everything together with the cluster?
This, yeah. So resource type, resource ID.
Yeah. So how did it identify the dots, the variable notation here?
Yeah. So it's resource type, which is in this case is Google Container Node Pool. The one that we're referencing is Google Container Cluster, and then this is a resource ID within this file. So up top it's primary. If we go up here, primary.
Yeah.
And then
I see.
You can reference things on this resource from there. So we have time name.
I got you.
And then Terraform builds a graph of the dependencies, and is smart enough to to know that it can't make this until the cluster has a name, kind of thing.
Right. I got you.
But yeah, this is where we set the actual node stuff, as you might imagine. So we want preemptible nodes. This is that ultra small thing.
The micro setup.
Yep, and then we want 10 gigs each. And then auto repair, auto upgrade. So Google manages the nodes entirely for us. Really, you're just saying that I want 3. And then these are outputs. So at the end of us running Terraform, it'll output these values. And so it's the same kind of notation where it's dots and text. Terraform doesn't like arrays, so there's kind of weird notation for that. But
I see.
But yeah, let's check on our deploying Kubernetes cluster. All right, so it's here. Yeah, this is basically all the stuff that we configured. If you go to workloads, we'll see nothing's running. I think somewhere in here, oh yeah, show system workloads. So this is all of the stuff that runs, and when you launch GKE clusters, they have a bunch of Google stuff running too.
Yeah.
It automatically comes with Heapster, which actually I don't think is a Google thing, but the metadata proxy is for the Google Cloud Platform metadata server, I believe.
Okay.
Same with like this GPU device plugin. It's like how you would integrate with the GPU.
Yep.
And then, I mean, it looks like we actually have one where that is unschedulable. Insufficient memory.
Oh man, we need to get more memory.
So we ran out of space already, apparently. But I wonder if there's a nice little dashboard somewhere in here. Probably under clusters, I guess.
Yeah, click on my name. Oh no, we're already there, right?
Well, it looks fine. I don't know. Maybe it might just have like a huge memory request.
Yeah.
So it thinks it needs a lot.
Mm-hmm.
But I'm actually going to delete this cluster, and then we'll make one that's more,
Yeah.
a little more declaratively deployed.
Terraform.
So if we go back, so in this repo I just linked to like the Google Cloud Platform Terraform getting started, which also only uses free resources, and they have you create like a VM. But so if you want to set up this walks you through setting up your credentials. Basically, you have to create a cloud platform project, which mine is called Code Magic.
Right.
I mean, it's not. I think you need to have billing enabled to be able to do the Kubernetes cluster, which is just it's entirely in the Google ecosystem. So like if you have like Google Pay configured anywhere, it'll probably have it already.
Oh, neat.
But other than that, you just have to get your credentials file, which you just find on your projects page.
Mm-hmm.
And then I had a little note here that I had to set the Google application credentials instead of the key file JSON. I don't know. It's just like conflicting things in the Terraform site versus the Google site, but
I see.
And then Terraform.
So is Terraform like a sort of Google managed thing, or is this like an open source third party?
Yeah, it's open source. It's by HashiCorp.
Mm-hmm.
So this, HashiCorp.
Okay.
And then if we go explore a little bit, find modules. We instantly see AWS everywhere.
Yeah.
But there's AWS modules, there's GCP as well as Azure, and then even like VMware, which is like on-prem.
Yeah, so we can potentially extend our sort of it's like all of our pipelines with various modules that they have support for.
Yeah, there's like multiple levels of kind of niceness to that, I guess. So like you can make any sort of like code infrastructure deploy pipeline. All you have to do is like know how to call Terraform, essentially. But then even within that, there's these modules, which these are all like, cloud specific modules. But you could make like a networking module that is parameterized to be able to swap out AWS versus GCP. So like helps you enable like multi-cloud type things.
Yeah.
So you're not locked in. But yeah.
Pretty cool.
And then as like there is this module registry, so like you can just download these and get going with how to set up these random things. So like Vault is a secrets management thing that HashiCorp has as well. So they have a Terraform module for how to deploy that on Google Cloud.
Okay, cool.
And stuff like that. But yeah, so we're actually going to use another Google Cloud thing. It's like the storage bucket, which is just like S3 in Amazon.
Right. Yeah. Okay.
So we're going to store our Terraform state there. So like the way
Terraform state. Okay, what is that?
Yeah. So Terraform is always going to be kind of every time you run a plan, it's going to diff what you like think you have to what's in reality. So the state is where it keeps track of what you think you have, essentially.
Okay.
And then, so by default, it's stored locally. Like in your little repo, you'd have like a .terraform state file.
Yeah.
But you kind of, first of all, immediately run into issues if more than one person wants to use it. You could check it into Git, which, might not be the best thing. But I also think it has like sensitive creds in it as well. So like if anything in your files or like these variables.
So the plan, yeah. Mm-hmm.
You know, so the state is actually kind of sensitive.
Mm-hmm.
But then the GCA using the Google Container Storage also has locking. So like if two people are running like Terraform at the same time, using the same backend, it like won't let you overwrite each other.
Right, and this is, and our backend is, what is this? What is our backend here?
It's the Google Container Storage.
Okay, yeah.
So
okay.
yeah, if I can actually navigate to it, I already made it.
Okay, so Terraform has to communicate with some sort of backend service to maintain the state then here, right?
Yep. Well, yeah, so here's our bucket, CodeMagic Terraform state.
Mm-hmm.
And then we go in, you know, it makes its own Terraform folder, which I think I actually specify. Yeah, I say like use GCS as the backend.
Mm-hmm.
And then the prefix is Terraform/state. So if we do Terraform, inside of here there's a state folder.
Mm-hmm.
And then here's like the default state.
I see.
Which this is probably from, I played with a cluster earlier today, just to check out GKE again. But I destroyed it afterwards, so.
So let's start deploying from Terraform.
Yeah, so.
If you're ready to.
Yeah, first step, we're gonna run the init and we're gonna pass in our backend using, you know, which is the GCS bucket.
Yeah.
And my terminal's gonna wrap annoyingly a little bit.
Yeah.
Terraform init and then backend.
Yeah, so you just gave your backend file here.
Yeah, so Terraform init also does, it goes through and looks at all of your Terraform code, which like by default it'll load everything that's like .tf. It's gonna go find all the providers and make sure it has access to that. So like Google is a built-in provider, so it always has access to it. But there's you can still do like external plugins. Like you can actually write your own providers, and then it just finds it by like binary name. It's like Terraform-provider-name.
Right. So there's like some namespace here.
Yeah. So and then init like links them together. So you only have to run it, you know, when you're initializing, as you might expect. But
say that again.
You only run init once, essentially, on your folder, unless you change providers or backend.
But if I change providers being so even if I like add like a new file, it'll still get pulled in, or
it'll be fine. Like I could make a new file that's like 2.tf, right, and make another cluster called secondary, and it'll still be fine. But if I were to do provider AWS in another file, then I would need to do an init.
I see. I feel like I would always init just to be safe.
Yeah, I mean, it was pretty quick too. It's not like you're really missing out. But then the other kind of thing that's important part of the flow is doing a plan. And, you know, I'm going to actually do it in the way that you're not really supposed to. So you see it's complaining down here that I didn't specify an out.
Okay.
So it's like you can set an out to be like sure that you're going to get the exact plan again when we do the apply.
To ensure that you didn't like if you like change a file.
Yeah, or if like somebody else is messing with your infrastructure. You know, because here it says plan is that it's going to add two. It's going to do our node pool and then our cluster. But somebody else could have like provisioned one while we were doing it, you know, and then maybe this should really be like one to change or something.
I see.
So your plan would be like out of date, and if you save it, then it'll tell you that it's no longer like the correct plan.
Oh, why? Oh, I see.
Because it's like not things have changed since you ran the plan, essentially.
Yeah, so it's not going to. It's not going to put you. It's going to do. So it's always going to do the right thing, but it's just not going to be expected. Is that what you're saying?
So if you do if I were to change the out, or to not use the out, I guess. Yeah, it'll do, I mean, exactly what you would expect generally.
To where it's setting up it's always going to set up like a sort of 2 node cluster in this case, or whatever. Like instead, like 2 to add, like it's always going to do 1 to change. Like if it detects something to change, right?
Yeah, the only thing that'll kind of be a gotcha for that is like certain things will recreate it, like it'll delete it and make a new one. So like if we were to change the zone, that's not something you can just update. It'll make a new cluster.
Somebody accidentally like clobber over somebody.
Yeah, and delete the whole thing. You can get in trouble that way too if you were to just delete a resource. Suddenly it's no longer there, so it'll be like, oh, so you meant to destroy this.
I see.
So it's important to run the plan. It's because it tells you what it's going to do. But and we go through here, it shows you everything it's going to do. Maybe not in the nicest syntax, but you can kind of generally get the gist. And then if there were a change, it would highlight the diff at that level.
I see.
But let's just apply. So it spits out what it's going to do again, and asks for you to say yes. And then, there's a way to like auto say yes essentially if you're doing this in like a pipeline,
like an app, like an apt-get style.
Yeah, so it's going to create. We see it's making the cluster right now, and if I actually go back to my console, usually takes a bit for it to show up, but all right, here we go. Yeah, so my cluster is being created. All the provider does in the back end is call like the Google Cloud APIs. Terraform is just kind of the orchestrator in a way.
Yeah, like it's just mapping your APIs, so it's mapping all of the syntax to just some APIs. I see.
But yeah, and then this takes a little longer than through the UI, mainly because we create a cluster and then delete the node pool and then make a new node pool.
Is there a way to get around that, or why is it so did we talk about why it does that?
Yeah, so I did that because that's what the Terraform docs say for the Google provider. My guess is that they just want you to be able to manage it separately. So like we could, in theory, I believe, keep our node pool here, but like swap out which cluster we're using. Whereas if we use the default node pool, it'll be tied to this resource. So then you can't keep that node pool around without some extra work, or maybe not even like really possible, I guess.
Okay.
Where if you manage it separately, they're 2 different entities and they're just tied together, which is a little more flexible.
Yeah, like the visibility of the visibility of the other one isn't there, right?
Yeah. But yeah, I could be wrong. I could if I delete the cluster, maybe it auto deletes the node pool, but I don't think that's the case.
I see.
That's also kind of an interesting point about this. How Kubernetes Engine works on Google Cloud Platform. Like if I go into Compute Engine, we can actually see the node pool that it's making.
Okay.
So it's like just like your normal. If I were to create a VM separately, without going through this, it still shows up here. And I think this is actually the default one. Yeah, it's got like 100 gigs. Yeah, so there's some like, this isn't the cheapest managed Kubernetes cluster, because I think you do incur like a little bit of cost just for this, depending on how long it's running.
The setup, yeah.
Yeah, and then if you do the way that our node pool is set up, right, it's 3 preemptible nodes, but preemptible nodes aren't included in the free plan. So you could do like 1 non-preemptible node and 2 preemptible nodes, and then the non-preemptible node will be free, which comes out to be like slightly cheaper.
I see.
For me, it wasn't really worth having a separate node pool for that, but But if you're trying to do like the poor man's load balancer, maybe you use your free VM to run like an HA proxy or like Nginx on it,
Right.
But could still be cheaper. Yeah, it tells you it's like we're still creating the cluster and we're 3 minutes in.
How long does it usually take to allocate the nodes?
So I've seen it. Normally the whole thing is like 7 minutes. So I think once we get our cluster up, it'll be pretty quick to get the other nodes.
Right.
Yeah, we see it's still attached to our default node pool here.
Mm-hmm. Interesting.
Yeah, it's interesting. It also gave us an older version of Kubernetes.
Yeah.
It's like 1.11 instead of 1.12.
Well, I'm pretty sure that was the default one, right?
I don't know. I don't remember changing it.
Yeah, we did remember here. Like, I'm gonna do this old one, the brand new one. Through here.
I see. Alright, so it actually just changed to the new node pool as I had it open.
Where did it say that?
So this used to say default node pool. Yeah. Now it's my poor.
Yeah, my poor node. Yeah, I got you.
I was like questioning if the default was 3 by 1 by 8, 1.8, but it's not. But yeah, so now we see that too. It's like creation complete, 4 minutes for the cluster.
Yeah. Mm-hmm.
And now it's making our preemptible nodes.
Interesting.
And then when this comes up, we can hit this nice little connect, and it'll open Google's Cloud Shell.
Ooh.
Which is just like a shell that has some common tools in it.
Okay. So we can just like SSH in. It's effectively SSH in.
Yeah. I don't think it puts you on. It doesn't actually put you onto a node by default. It puts you onto like. It's also included in the free tier. They mention it somewhere. But it's like your own little node. Yeah, Google Cloud Shell. Free access to Cloud Shell, including 5 gigabytes of persistent disk storage. So like your home directory inside of the shell gets persisted.
Right. Yeah. I see.
But
so you're basically effectively. It seems like you're basically SSHing it into some Google box, but then you need to communicate with the cluster you're talking to.
Yeah, so I just hit the connect and then like run in Cloud Shell.
Mm-hmm.
And then we also noticed like Terraform spit out all of the stuff that we would need to be able to connect to it locally.
Mm-hmm.
But like I don't really want to mess with adding that to my kubeconfig.
Right.
So I'll just use the gcloud container clusters command, which is basically like gcloud container clusters, get credentials, name, and then zone, and then your Google Cloud project too. And it sets up your kubeconfig. Which the cloud project thing also like pre-populated, so I could do this too. But now I have kubectl. So this kind of shows us basically what we looked at before, where it's workloads.
Yeah.
And then show system workloads, which Heapster is now able to start apparently. But yeah, so you see it here. And then I can also do it locally. Yeah. So I got all my stuff running.
Oh man. I love technology.
But yeah, so you can run. I have a.
Yeah, can we?
I would say I have a little Nginx. I have a little Nginx thing prepared somewhere. I think it actually just hosts my resume. Oh, I think it's 2. So we'll open this. So this is what you deploy.
So the YAML, so the YAML is just a very basic config of your pod. Is that the verbiage?
Yeah. So we're gonna deploy a deployment, which is at the end of the day is going to make a pod, and that's
yeah.
like.
So what other kinds are there?
So the deployment actually deploys a replica set, and the replica set is what's going to be like this replica's number. So it'll always make sure that there's at least one pod running.
Yeah.
Where we could set this to 2, and then it would always make sure there's 2 running.
Yeah, but it would take two nodes on our cluster, or
so actually by default, I don't think it's smart enough to spread it out. So it's just gonna deploy 2 somewhere.
But it could, somewhere, yeah. So it could potentially live on the same node.
Yep. You can do. There's like various scheduling things you can add, like pod anti-affinity, where you just say like these 2 pods shouldn't be next to each other on the same node, preferably.
Right. I see.
Then it would do it where it would schedule across 2. But by default, it's just whatever. But yeah, so this runs Nginx, which is just like reverse proxy web server.
Okay.
And it mounts in an HTML page based on this config map, which a config map is just kind of a wrapper for generic configs. It's like key value. So we're saying resume.html is the key, and then we're gonna mount it to this file, like index.html. So it's gonna end up being at this location inside of the container, which this is the default serving location for Nginx. That's why that works.
Okay.
And then we can look at the config map as well. So the order's a little wacky here, but kind is config map, just like deployment was, kind. So the name, resume HTML. And then this is just like a file that's in here.
Yeah, I see. Interesting.
So, yeah, if I were to do apply and then get the config map going first. We should, be able to actually see that in this UI over here. Yeah, so now my config map is on the cluster.
And that's just I see.
It's just a config, right? Like this actually isn't that interesting. Other than the fact that, it was that easy.
Right, okay.
But if we were to do the resume pod, or like the deployment, this one will actually probably take a little bit longer. Yeah, so it's still container creating. If we show it in this nice little UI, now it's okay, or like status okay.
So now we have an Nginx server running.
Yep, and then so how we were talking about, ingress and all that kind of stuff.
Yep.
So right now we actually can't really get to this because all of the IPs are internal, which I think we can actually see. If I expand this out, yeah, so we have IP, and it's just 10 dot, so that that doesn't resolve from externally.
Okay.
The easiest way is to just port forward. So there's kubectl port forward, and you can do, I think it's pod, and I already had that copied.
Okay, and so that's the pod. That's the name of your.
Yeah, so we're going to say 8080 locally to 80. And we're going to hope that that's the correct syntax.
Fingers crossed.
Yeah, so if I come back over here, and I go to 8080, yeah, we see our page.
Oh, cool.
If we were to, make a change, which easiest way is probably this config map. We'll just change my name to be spelled wrong. Well, it was just Josh, actually.
Couldn't handle it.
Yeah, I can't be spelled wrong. Oh, this changed my folder. You know, I have a bunch of aliases set up, so you don't have to type this whole thing every time. So if we reapply this and refresh, you know, nothing happened.
Yeah, it's taking out. Okay.
Well, so these volumes don't remount automatically. And the easiest way to kind of get it to reload is just kill the pod.
Mm-hmm.
I mean, maybe not the best way to do it, but normally you would run things with more than one replica.
With more than... Okay.
So killing one wouldn't really matter. It would just kind of recycle it. But I think I need to say delete pod. So I deleted that. It's actually hanging. Well, let's refresh. So I think it might have already come back. Yeah.
Oh no. Uh-oh.
Yeah, see, there's a new one that's running.
Yep,
21 seconds old. And now... we're not loading. Oh, I bet my port forwarding's not going to work.
Yeah.
Yeah.
Yeah, because you're mapping it to a different...
Yeah, this pod doesn't exist anymore. And then I didn't copy that right. Uh-oh.
Just get those pods again.
Yeah. Yeah, that was not the right value. There we go. And now it's Josh.
Oh,
cool. But,
sweet.
Yeah, I guess that's another, if we were to scale it, you know, we just say 2.
Yeah.
Not that one, but the deployment. Which, I mean, it should be, we're actually only going to the one pod, you know, so we won't actually really see it.
Mm-hmm.
But we see there's 2 out of 2 pods.
Yeah, and if we do
and there's
pods,
both. Yeah. Created 2 minutes apart kind of thing.
Yeah, and if we do get pods, we'll see that they're different.
Yep. Yeah, so now we have 2. Both running.
But one of them we wouldn't necessarily be able to talk to, right? Because we only port forward one of them.
Yep.
Nice. Yep.
Yeah, so the way the load balancing kind of stuff that you do is actually what Google is so kindly telling us right here. They want us to expose it with a service.
Mm-hmm.
Which I'm curious what they'll do. Let's just... yeah, so 80, and then this is actually 80 as well. TCP. And this is what I was talking about, where they just defaulted to load balancer, but this costs money. So we could do node part, and that would make it so that all of the VMs, if we go get their external IP, we could hit it.
Mm-hmm.
You just have to open a firewall rule.
Right.
Which... let's see it. Yeah, so now we have the service. You know, it shows that it's this deployment, but it's actually serving these 2 pods as the main thing. Oh, what does this do? Oh, yeah. See, they have this nice little port forward command already for you.
Oh, interesting.
You actually don't need to do this pod selector thing anymore, though. You can just do svc/service name, and it'll figure it out.
Cool.
But yeah, that's about it. I'm gonna delete. Well, actually, this doesn't matter. let's go through the delete part of our Terraform thing.
Yep.
Just, in case $5 a month is still too much for you.
Clean up our mess.
Don't wanna leave it around. I'm not in the right folder anymore. It's just Terraform destroy, and it'll ask me if I want to do it or not. So yeah, it's going to delete our cluster and our preemptible nodes.
Cool.
And yes. And I guess we should be able to see that pretty quickly. Yeah, cluster's being updated. I bet it deletes the nodes first. So it's like, deleting it's updating the cluster to not have the nodes, and then it'll delete the cluster. Sense. Just a little quirk, I guess, but it's nice. Terraform also has a Kubernetes provider, so we actually could have automatically provisioned all of these things as well.
Oh.
And kept it in sync, but there's also some more Kubernetes native ways to do that, but
I see.
Probably go over it at some point in a future stream.
Ooh, tease.
Yeah. But other than that, do you have any?
Well, to destroy. No, I think that's it. I think
you're fully on board the Terraform and Kubernetes train now.
Easily.
Mm-hmm. Well, cool. Thanks for coming.
Yeah, I guess so. Yeah.
Oh, go ahead.
I guess. I think. Yeah, it's just a very broad thing right now. Like trying to visualize.
Mm-hmm. Yeah, I was thinking it's now that we can get our nice little cluster easily. Mm-hmm. You just might see why you would even want Kubernetes more so in the future. Hosting my resume isn't really something that you necessarily would spin up a cluster for.
Mm-hmm.
So hoping to see more of a real app that's a little more distributed.
Right.
Yeah. We touched on it briefly with that service, but it also handles the service discovery and load balancing for you that way.
Yeah.
Which would make more sense if we had more than one thing running and it wasn't just a static app.
Right. Yeah. Yeah. If there was an actual processing happening.
Mm-hmm. But yeah. So that's probably where we'll go next. There's also workflow engines that people built on top of Kubernetes because you can just use your containers as kind of the building blocks everywhere, and then Kubernetes will schedule it for you. So you just need something to kind of control the flow.
Okay.
That's that's another interesting area. Looks like our cluster is finally starting to be destroyed.
All right.
I bet. See, it's Google probably bills you for all of that time too.
Yeah.
But yeah.
Cool.
So
awesome. Thanks.
Thanks for hanging out.
Thanks for having me.
See ya.
See ya.